Alright, we'll now have a look at the relationship between current, voltage, and resistance. In year 11 we did experiments, those of us that did double science. We saw that as the voltage increases, the electrons experience a bigger force or push. So the electrons move more quickly, and the current increases, i.e. the current is directly proportional to the voltage, or I is proportional to V. Double the voltage means double the current. As the resistance increases, the current becomes smaller, i.e. current is inversely proportional to the resistance. I is proportional to 1 over R. Double the resistance means half the current. So we get I is proportional to V over R. In fact, I is equal to V over R because of the way that we've defined the three things. The way that we define an amp, a volt, and an ohm, we don't need a constant there. So V is equal to I times R. Okay, this is what's known as Ohm's law. Okay, so if we do a simple experiment, and we did do this experiment last year, we find that as we increase the voltage across a resistor, the current will increase. And so the gradient here which is the increase in voltage divided by the increase in current. This is V and this is I. Let's draw that line again. So the gradient here is V divided by I, which is voltage divided by current, and V over I should be equal to the resistance. And what we'll do is we'll just test this in class with a resistor that we know the resistance of, just to double check that this relationship is correct. So in this case the resistance is constant. It doesn't depend on the current through it. We call this an ohmic resistor. The bigger resistance needs a bigger voltage to push the same current through. The gradient is the resistance only if the resistance is constant. In general, the resistance is just the ratio R equals V over I. There are many things, if we push a larger current through it, like a light bulb for example, the bulb will get hot, the resistance will increase, so we won't get a straight line here. Then we just need to use a single point and divide the voltage by the current. Okay, so here are a couple of homework questions. I recommend that you have a go at those before you watch the rest of the video, but I will work through these now. So, state the voltage gain in the cell, 1.5 volts. The voltage drop in the bulb therefore must also be 1.5 volts. And there's a rule here that any voltage that we gain in a circuit must also be lost by the time we get back to the same point. So if we go around the circuit, we gain 1.5, we don't lose any in the wire, and so the only place where we can lose the 1.5 again is across the light bulb, and we have to lose it by the time we get back to the start of the circuit. Calculate the current. Well, we know that R is 12 ohms, and we know that V is equal to IR, so I is equal to V over R, which is equal to 1.5 over 12, which is equal to 0.125 amps. What happens to the current if a second cell is added in series? So two cells in series means twice the voltage, i.e. double the push. The resistance remains unchanged. So the current doubles as I is equal to V over R. Okay, Amelia's radio has a resistance of 100 ohms and needs 30 milliamps to operate. How many 1.5 volt dry cells does her radio use? Okay, so we have R is equal to 100 ohms, and I needed is 30 times 10 to the negative 3, and V is equal to IR, which is equal to 30 times 10 to the negative 3 times 100. So we need 3 volts, and so number of cells needed is equal to 2. We need 2 1.5 volt dry cells plugged into in series to get 3 volts output. Okay, in the next video we'll have a look at electrical power.